Good evening. It's a pleasure to be here again. I was here last year. I was on the panel last year. This year I'm chairing this event. Collider Science is a fabulous new organisation founded by Tina. Our aim is to inspire curiosity in science, technology, engineering, mathematics, ethics, responsible innovation, all the things that build a good society and one that can approach global challenges using technology, science and the integration with other ways of looking and describing the world so we can solve some of the big global challenges rather than just protesting about them. You've got to do stuff. And never has there been a better time to take on these challenges, and never has there been a better cohort of young people around the world to do it. I know a lot of people say it's the young people who are going to save the planet. Well, it really is. But it's the young people who are curious, who look at using technology and their science, technology, engineering, mathematics, all of their skills to grow creativity, to have creative solutions and innovative solutions to these big challenges. So we're promoting Collider Science all around the country from now on. This is a big challenge that needs to be taken on, and so we're filming this evening. It's all right, we're not filming you. That would be breaking the law probably, but we are filming us. We are filming your presenters this evening. But first, a message from our sponsor, as many people say. Sir Paul Nurse, a UK Nobel Prize winner, when he was emailed by Tina a few years ago, within 10 minutes he responded to say yes, he was on board. Now you can all read. So this is Sir Paul saying he's delighted to support Science Question Time. You can read on that sentence. It's in your programme. I won't take up your time now with that. Just goes so that when you have someone who's forthright in their science, who's represented the Royal Society, who represents the UK as a Nobel Prize winner, standing behind the importance of growing Science Question Time, Collider Science, a development of diversity, in particular in the sciences, technology, engineering and mathematics, and the integration of that diversity across challenge solving, you really know you're onto something. So with that in mind, this evening we have a really skilled polymath panel of very interesting people who have done great things and are doing even greater things using their science and technology. We could have had any number of people. We have here, just at the front, a lady called Jackie Bell who works at Imperial College with me, and Imperial and Collider Science are combining our efforts to help promote the diversity in science, technology, engineering and mathematics, the STEM subjects in particular. Now, Jackie, is a particle physicist, and she's going to be probably the next UK female astronaut. So that's what you get from studying deeply and being curious about science and everything that goes with it. And hopefully you will all be inspired by our panel members this evening to take a deeper look at STEM subjects and be curious about the world that you live in. So I would like to introduce our first speaker this evening, Becky Inkster, who will describe herself in just a couple of sentences before she goes on to talk through her presentation. Becky, please.
Okay, good evening everyone, and thank you for your time. I thought I'd dress up for you all, so and that's not me in the photo, just so you know. So, I'm just going to put this. So I have 5 minutes to talk to the youngest audience I've ever spoken to. So here we go. So the easiest way to describe myself is through pictures. I'm very visual, I'm very creative. I had to suppress this for the longest time because I thought that I had to go into medicine, I had to do all of these things, but you can do both, okay? So you can be very creative and artistic, and you can do all of the tech, all of the biology, etc. And so this is just an example of some of the things that I think about. And my career really took off when I decided to become self-employed, and I was brave, I had a little girl, and I just went for it, and I allowed my mind to expand and explore. And so I'll cover two examples of the work that I do and how it relates to some of the, I guess, the STEM subjects. So I'll cover the first. I'm aware of a young audience today, so does anyone know who Kendrick Lamar is? I thought so. Okay. So we've got some Section 80 kids here. Okay, so the topic is DNA, data, and diversity. So I'm going to be very faithful to that subject. I'm going to cheat with my first example though. So there's a song called DNA by artist Kendrick Lamar, who is a world famous hip hop artist, a scholar. And this is off an album called Damn in 2017. And what's really interesting about this from my perspective is in mental health, the area that I study, mental health, innovation, and biotechnology, is that this artist, his lyrics are so powerful. So we dissected these lyrics and we found biopsychosocial, I guess you could say, underpinnings in this music, okay? So we published in Lancet Psychiatry, a very prestigious journal. We're ticking these boxes. And then it went viral. So the scientific data that we wrote about in this article reached a whole new crowd of people. So 1.3 million people in 72 hours, okay? So science is at a different stage where you don't necessarily just stand in front of some people. We can connect with the whole world, and we can use topics that relate to many people and bring the science to where the people are, okay? So that's just one example of the work I do. I do a lot of natural language processing, okay? So this is one example of looking at hip-hop lyrics. Again, I'm just trying to keep it a little bit fun and light tonight. But in hip-hop lyrics, you've got a lot of terms. Some are related to drugs, okay? Disclaimer, there will be some terms mentioned about drugs. This slide is just showing you that this is what the doctors feel comfortable with. These are the terms, you know, the promethazine, the codeine. This is the medical training school terms. And you'll notice a flat line. So what I'm showing here is across time, as we just go across the screen, and the frequency of the word usage in a particular song across all hip-hop songs across 3 decades of hip-hop music, okay? So we're seeing a flat line. Nothing really is picking up a signal in when we use the doctor's terms to look at the hip-hop lyrics. Now, the data comes alive when we start to use the terms that some young people are using, such as scissor, etc., etc. So, and we're starting to see trends, socio-political trends in the data, that terms become in fashion, then they go out of fashion. And what's happening with these words, you know, what's driving what? So we can start to look at all these effects of different words across time. But it's important that we have to collect data that is diverse. Okay, we don't want to just ask the doctors what are the terms, etc. We need to get out and ask young people what are the terms, what are the cultures. That will make our data much more valuable, much more rich when we start looking for associations with mental health and trying to protect people with resilience. And so this is just another example when we use our natural language processing of different things that we have to consider. And just in the interest of time, I'll just point to the object on the left, which is if you were using an algorithm and just kind of churning through the data, you would miss a very important signal here. So it's just a Sprite bottle. It doesn't look assuming or strange in any way, but of course it's purple. So does your algorithm and does your study design account for the fact that there's promethazine and codeine inside here, which is cough syrup, which is scissor, okay? So we need to start to, when we're doing our stem cell subjects and when we're looking at data using natural language processing and words and that sort of thing and algorithms, we need to really understand what we're seeing, and the language is so diverse that if we don't pay attention, we won't capture the real signals that we're trying to look for. And I'll just get a little bit technical here. So one of my interests is genomics, even though I also do research inside prisons. I do research related to outer space, challenger banks, fintech. But this particular example relates to something called sociogenomics. And we're at a time now with social media where we can start to look at lots and lots of data. There are ethical issues and governance issues that we have to be very careful with and very mindful of. But we have an enormous opportunity to look at people's social networks and also the impact of their genomics. So trying to bring in the DNA, the diversity to this second example. There's a couple of research papers showing that hens, and I mean kind of chicken farm animal hens, they clean their feathers in a way that is dependent on the other hens around them, and dependent in a way that relates to the genetics of the hens around them. So they'll have more clean feathers if the genetics around them is a certain way. Now, there's a lot more behind the scenes, but you could also look in humans where educational attainment is influenced by the genetic landscape around you. So we need to start looking at genomics on a social level and how people interact and bring their genomes into your situation. They might protect you from different immune situations which you couldn't protect yourself. So there's a lot of things we can explore using social media data, but also genomics across wide groups. So I just wanted to, in 5 minutes or less, just to explain that there is a link very easily between DNA, data, and diversity. And when I was asked to give this talk, it was so super easy to come up with these examples and many more, because all you need to do is use creativity and follow whatever you're passionate about. And there's always a way to link it back to the technology, to the science, to the biology, but be brave and explore and find other things that are interesting and bring it into your interest in STEM as well, because that's where a lot of innovation and impact on society can happen, as I've experienced in my own research. So thank you.
Question, just to leave you thinking about. What you just described to us is obviously the integration of things that we call personal data with genomics, with biotechnology, with societal ethics, with all sorts of other things, crossover with language, natural language processing. So when someone says, oh, I want to go into data science, what do they really mean about going into data science, which is obviously applicable across the board? And it might be a question that's very valuable to people here to give an answer to. You know, I want to be a data scientist. What does that really mean? So, thank you very much, Becky.
Okay, would you like me to answer later?
Well, now, think about that afterwards. We're going to have the presentations. I'm going to give each of the presenters a question to think about and just sort of get these going. And then we'll have an hour, I think it is, or thereabouts, for Q&A afterwards, where you can ask anything you want. So, unfortunately, this evening, Toby Call couldn't make it here because, and he's in the programme, he's stuck on a Eurostar train at the sort of border between France and England. I wonder what that's all about. Anyway, we're very fortunate to have Nikolai Visakov here. Nikolai is the CEO and founder of a company called BrainPatch. It's astounding stuff. So, Nikolai, please.
Thank you for the invitation. Sorry, it's really last moment, so I don't really have a. Wow, thank you. I like that slide actually. I'll keep that presentation. I'll keep that slide as a presentation. So I'll talk about my career path. Hopefully, maybe some of you will relate to it. Some of you will be inspired. And started with falling in love with chemistry at school, and I think this is a fascinating subject, and it quickly got boring, and moved on to organic chemistry. Then I decided, okay, I want to do university, I want to do biochemistry, and it kind of built on into cell biology. And then when I was finishing university, one of the lecturers, Dr. Jane Safel, she organized a practical where we were growing nerve cells. These cells, like the ones you see on the picture, are fascinating. They are so beautiful, especially when you realize that this is something that you've put in there, this is something you've grown. And that experiment has inspired me to go on the path of neuroscience, and my kind of passion, my idea was to try and engineer that beauty, try and engineer that growth. So I wanted to get, I realized that this is as an insurmountable challenge. I thought that this is something where you need a broad, kind of broad approach. And I did the course so I did Bachelor's in Imperial College London, then I did my Master's of Neuroscience at King's, and it was a very it covered all the aspects of neuroscience from, basic cell and molecular stuff, going all the way into, mathematical modeling, artificial neural networks, covered just every, and then, to neurology as well and other diseases. And then, after Master's, the natural path is to go for a PhD. And this was an interesting experience in terms that I started with one project, and then due to circumstances outside of my control, it was Imperial College, they've decided to make one supervisor redundant. Then I started a new project, and the next supervisor was made redundant as well. People were starting to think I'm a bad omen, and didn't want to accept me. And I ended up doing this project pretty much by myself. This gave me a good idea of how to work independently and be in control of your own project, how to estimate the costing, how to arrange, how to find help where your supervisor isn't available. And I think this wasn't in vain. I think this was an experience that helped build this character inside of me. It helped build the resilience. It helped build the curiosity to try and explore new things. And then, so after I finished my PhD, and I was doing something very, very fundamental, looking at how the connections between the neurons are formed, and this is a fascinating topic. I mean, there are, in each and every one of our brains, there are about 80 billion neurons. So each neuron has between 100 to 10,000 connections. Now think about it. That's tens of trillions of connections in each and every one of your brain. So this is why, that topic of studying how these connections are formed, how they find each other, how they make sure that the signaling between those nerve cells is correct. That was really interesting. So when I finished my PhD, I went to work into industry. And industry is very different from an academic environment. You get different goals, you have different sort of health and safety standards, paperwork, etc., etc. But what was really interesting is in industry, and what really inspired me is that notion that I am doing something. So I was making stem cells for stroke patients. So, I was doing the same thing as I would do in the lab, just growing cells in a dish, but then realizing that these cells are going to make a difference to somebody else's life and the life of other people around them. And that was really, that was very inspiring. So for my next step, I went back into academia, and I was doing something less fundamental and more applicable, studying pain, particularly chronic pain. So it's not something that, pain affects everybody. And actually pain is a normal thing. So that makes you realize there's something wrong. But in some people, that feeling of pain is, it's abnormal. So they feel too much pain when they shouldn't. They feel constant pain. they feel phantom pain of a limb that's not there anymore. So this is what I've been investigating, and this is what this is like led me to discovery of a new strategy that pharma companies could then take on and investigate new targets for relieving pain. And then, nature of academia is such that you have a project, you have a contract. Now the project runs up till the end, and then you gotta think of something else to do. So I was, thinking, applying to different places, thinking what to do next. Should I stay in the UK? Should I move to States? Should I move to Switzerland? Switzerland is a very attractive place for science. And it just happened, a coincidence of events, the power of serendipity, that I had a friend who was like a serial entrepreneur. So he had no scientific background whatsoever. He just had companies that he helped build from 0 to 1, and then, build them, then sell the companies, and then move on to the next stage. That's what we call a serial entrepreneur. And we started bouncing ideas about what is going to be the next big thing in neuroscience. And we realized that there are technologies that are coming out in what is called a non-invasive brain stimulation. And all it is just putting small currents across the scalp of your head, and what it does, it creates electrical field. That electrical field interacts with the brain inside of your head, and then that does a number of things, and there have been studies showing it's effective for reducing cognitive decline in Parkinson's disease. Some other studies show it's affecting Parkinson's. So there's been recently a trial for epilepsy, but also in the non-clinical space, there are devices out there that they sell for motor enhancement, for neurogaming. There's one for productivity, creativity, and they all have one and the same thing, that is one and the same common theme, is that they have this one-fits-all approach. And coming to the theme of diversity, I don't think in any part of our body we're as diverse as in our brains. Your brains are all very different from my brain, from your brain. I mean, they're completely different, and moreover, they're different in different states. So my brain in the morning is different from my brain at midnight. So it's what we've realized is we need to make a protocol that is adaptable for your current state of the brain. So it's not a technology that's been available before. It's something that I have thought up. It's something that I talk to my friends. And again, the other part of diversity is one of the guys is a physicist. For some reason, physicists have a keen interest in neuroscience. Another guy is a machine learning engineer. So there's an artistic director who's just basically helping create something beautiful and visual, something like that probably, not as good, but we're getting there. And putting together this team and working on this enterprise has been the biggest challenge I've had so far. In the words of one of the famous entrepreneurs, Ben Horowitz, it is a struggle, but this is something that I feel passionate about. This is something that I love doing. So, and what I wanted to end the short talk with is inspiring you to try different things. So the world is yours. Try this, try that, try another thing, until you find something that you absolutely love doing, and then you will be successful in it. Thank you.
To leave you with, you described there at one point a sort of coalition of all different sciences and technologies for something that most people don't attribute to have any kind of science involved. In neuroscience, most people think of as chemistry, but you said physicists were involved in it. Yeah. You talked about a huge requirement for understanding data, about connectivity, complex systems, everything goes into that. Who here plays computer games? Do you realise that computer games are entirely mathematical? That if you're good at maths, you can write good computer games. If you're not good at maths, you can't. It's not about animation, it's not about pictures or anything like that. It is all about maths. If you're interested in artificial intelligence and machine learning, all about maths and statistics. So, yeah, do a statistics A-level if you can. It's really, really interesting. It will help you. So, Nicola, what I'd like to leave you with, if you had to do it all again, would you do anything different? Would you study anything different? And what would you study more of? So, with that in mind, I'd like to introduce Caroline Leroy. Caroline is doing some incredible work at King's. Now, King's College, of course, is related to the same King for King's School here. So, there's a sort of symbiosis between... there you go. So, Caroline, there's the thing.
Thank you. Okay, so I will be talking to you about how we're using twins, so twin siblings, to understand how the gut microbiome plays a role in health and disease development. So to start with, because I'm not aware of what everyone knows or not, a bit of definition, what do we call the gut microbiome? So when we refer to that, we generally talk about the collection of microbes that we have in our intestine or the digestive tract, and that contains bacteria, of course, but we can also talk about viruses or things like yeast or fungi. So we know that we have trillions of them in the large intestine, and what is interesting is that although we will all share some of the same microbes in this room, each of us is unique, so we all have a unique set of microbes that we can consider as a sort of fingerprints. So how do we characterize those microbes that are in our gut? So we start with a fecal sample, and from there we can extract the DNA that is in all of those bacteria and microbes that we find in the sample, which means a lot of DNA, and start sequencing it. So we end up with a lot of data, obviously. And this data is then after used to try to see who is there, because each of those microbes will have a unique DNA or genetic identity, but also what they can do, because we have access to the genes that they carry, and therefore we can find out what they can do in our gut, such as what type of food they can digest for us, or what toxins they can produce. So I said that we were all unique. So what defines our gut microbiome? We have a lot of environmental factors that comes in play, and here is a list that is non-exhaustive of the things that will influence the composition of our gut microbiome. And obviously, we have things that look obvious, like diet, because it goes through the digestive tract, so it will reach all microbes. But things like social interactions are also important. So you will share microbes with who you live or who you're at school with, for instance. But people you don't interact with or you're far away in terms of geographical location, you might be quite different to them. Things like traveling is also important and might affect your gut microbiome. For instance, I'm quite interested in antibiotic resistant genes that are carried by microbes, and we found out that the more you travel, the more you're likely to carry them. One other thing that is very important outside of this environmental factor is your own genetics. So the genes that you have yourself and what makes you unique will impact the composition of your gut microbiome. And that's what we try to study in our lab. To do that, we use a twin model. So we work on the Twins UK cohort that is composed of 13,000 twins that are registered now. And we have a mix of monozygotic twin pairs. So those monozygotic twin pairs will share 100% of genetic identity. And we have some dizygotic twin pairs who will share at least 50% of genetic identity. And what we do is to look at the similarity of the gut microbiome between monozygotic twin pair and compare it to dizygotic twin pair to try to see what is the proportion of genetic that is in play in shaping the gut microbiome. And therefore we access to several information such as what we call heritability, which is this proportion of the gut microbiome that is shaped by our own genes, and also information regarding the environment. So what proportion of the gut microbiome is shaped by the environment. From there, because we have the genetic information of those twins, we can find out which genes are important in shaping the gut microbiome and also which environmental factor, because we have a lot of information on what they do, where they live, and what they eat. So why is all this very important? Because what we also know is that a person who is healthy will have a very different gut microbiome to someone who has a disease. And interestingly enough, when someone develops a disease, their gut microbiome shifts. So obviously, understanding those factors, genetic and environmental, that trigger those changes, can help us to develop things that can help us to prevent or reverse these changes. So how can we go back to our healthy state with a healthy gut microbiome? And finally, and that will be my last point, we can also try to see how to avoid these changes and how to use the environment and what is around us to prevent disease development through the gut microbiome.
Fascinating. Something for you to think about, because I need to know the answer to this. We often say you are what you eat. So quite obviously, from Caroline's work about the microbiome, the bacteria inside your gut, that eats what you eat. So maybe there is a bigger connection than we've ever seen before between our food, what we eat, how we eat it, and our mental health. So I'd like to ask you, do you think that's the case? And to think on it, and at the end, well, when we go into the science question time, that's what I'd like to start off with. I'd now like to introduce Carl Miller. Carl is a really fascinating chap. He's going to tell you a little bit about his story and his journey. As well, actually, he's research director at Demos. Yeah, and a lord of the new digital age, I think.
Lord, yes. All right. Hello. Good. All right. So what keeps me up both day and night is a preoccupation with trying to work out what on earth is happening to all of us. How the kind of digital revolution is reaching through the screen and changing what we're like. I've just come back from a strange journey, a kind of winding, sometimes quite frightening one, where I've just been going around the world for the last kind of year and a half, basically trying to ask who is in control, who really holds power, why is society changing the way that it is. So in order to give you a kind of bit of a kind of inspiration, in 5 minutes, here are 5 people or things that are changing the world with tech. And maybe you're going to be number 6. Okay, you ready? Yeah. Great. All right, so maybe you're going to become a meme manager. Who knows about Grumpy Cat? Who shared Grumpy Cat? By the way, I didn't believe that there were so few gamers in the room before. We're going to come to that in a minute. All right, Grumpy Cat's just a funny-looking cat on YouTube. But did you know that it's now worth a reported $76 million? You could buy Grumpy Cat Christmas cards, you could buy Grumpy Cat the game. Grumpy Cat's owner is a woman called Tabitha Bunderson, who has given up her job to manage Grumpy Cat full-time. She travels around the world with Grumpy Cat, opening up shopping malls, opening up supermarkets. Have you got a funny-looking cat? Load it onto YouTube and maybe you can become a meme manager as well. So that's person number 1, virals. Virals are massively changing the kind of ideas that we encounter. They're changing the kind of things that we see every day. Number 2, John Never Die Jacobs. You won't have heard of this man. Has anyone? So who is a game? Who plays video games? Come on, I don't believe it was so few. Yeah, most of you, right? Because almost all of us do actually play a kind of game nowadays. John Nevidar Jacobs played a game called Entropia Universe. Entropia Universe was this huge, massively multiplayer online role-playing game, and he mortgaged his house to buy a digital asteroid in this game, an entirely digital asteroid. Now, he charged people real money to bring their entirely digital menagerie of creatures into a zoo, and then people would pay money to see the zoo. He sold mining rights on his asteroid. He built a club called Club Never Die. It was the hottest party spot in the whole of Entropia Universe. And people again would pay real money to go to Club Never Die. He actually got married in Club Never Die at the same time as he got married in real life. That's John Jacobs for you. And he sold the whole thing, mining rights, asteroid, and Club Never Die for $500,000 about a year ago. So maybe you're going to become a digital entrepreneur. Maybe you're going to be buying and selling. The first millionaires are now buying and selling digital real estate. Or maybe you're going to become a hacker. Now, if you go to Las Vegas once a year, every year, as I did, you'll see that suddenly you're hanging out at Snackus Maximus by Caesar's Palace, marbled edifice kind of soaring above you. And suddenly the casinos start wheeling in their ATM machines. They stop taking cards. You see the bus network literally crash as a whole new player comes into town. Kind of Shuck Blue Mohawks blockchain tattoos. Once a year, every year, tens of thousands of the world's best hackers all descend on Las Vegas. And all that they are interested in talking about is technical skills. Now, these aren't mad, bad, dangerous criminals. Actually, most of these people actually work in keeping us safe. They're there actually fighting the people that are trying to undermine the basic ways in which we connect to one another, basic ways in which we bank. But if you want to be a hacker, it's all about pulling apart the black boxes and understanding how technology works. And in front of on glowing neon stages, in front of literally 10,000 of their peers, I saw hackers hack laptops using light you couldn't see, using sound you couldn't hear. Another hacker stood up and proved that he could cause any wind turbine in the world to burst into flames. Another one stood up and announced the discovery of DeepHack, the first use of an AI finding vulnerabilities in websites. Hackers don't care who you are, they don't care what you look like, they don't care how old you are. I saw 9, 10-year-old kids learning how to pick locks, learning how to reverse engineer phones. The only thing they care about is what your skill is with technology. So maybe you're going to become a hacker. Or maybe you're going to become a citizen journalist. One of the people I met on my journey was Elliot Higgins. Now, Elliot was sat in his room in Leicester. He'd been working for a charity, he'd been laid off, he got the first job that he could find. It was an administrative assistant for a manufacturer in Leicester. But every day he went onto the comment threads of The Guardian, and every day he'd look at stories that were being written by professional journalists about the wars in Syria and Iraq. And he got really good at learning about these wars just looking at social media, looking at those arid battlescapes on YouTube, looking at things that were posted on Twitter and Facebook, and VKontakte and others. And he began to actually be able to prove that some of these journalists were just wrong. They just weren't describing the wars correctly. And his reputation began to grow. He got a small number of scoops, and he set up his own blog. And then a few years ago, some people might remember this, MH17 happened. Do you remember MH17, the Malaysian Airlines jet? 298 people killed, clearly shot down, and no one claiming responsibility. Well, Elliot did something about this. He left his job, he set up a citizen investigator network called Bellingcat. And for years after, Bellingcat spent hour after tedious hour, hundreds, thousands of them, pulling together everything that they could find about anything that might have shot down MH17. It began on the day of the crash itself when he saw an image with a small green vehicle kind of jutting around a corner. And of course I wouldn't have known what on earth that was, but Elliot spent years already getting really good at identifying military stuff on social media, and he knew this was something called a buck launcher, something that could actually shoot down a civilian airline. They pulled it all together into a dossier. They traced this buck launcher driving out of Russia into eastern Ukraine. They finally found an image of the buck launcher driving back without one missile. They handed the whole dossier over to the investigation team that was investigating the crash. That just several months ago came to the same conclusion as Elliot. And Elliot went from the comment threads of The Guardian to the front page of the New York Times. And all of that without ever being a professional journalist. And maybe you're going to become a citizen investigator. There are so many amazing opportunities now to break huge stories, to chase down the corrupt, just looking at what things are being posted onto the internet. Or lastly, maybe you're going to be a digital democrat. So one of the people on the journey is Audrey Tang. Now, no one would have heard of Audrey, I'm sure, here, but Audrey began, I'm not saying you do this, but she began her life as a high school dropout. She dropped out actually at the age of 12 to learn more about technology. And she went to Silicon Valley, and she became a Silicon Valley entrepreneur. She was working on a Mandarin language search engine, and she did as Silicon Valley entrepreneurs sometimes can. She retired at the age of 30, went back to her native Taiwan and became a civic hacker. She really wanted to change the way that government worked. She felt it didn't work well for people. It was too closed, it wasn't open enough, people didn't have enough say. And in 2016, the Sunflower Revolution in Taiwan happened. People poured through open windows into the parliament. They occupied it because they thought that parliament was too closed. And in the wake of that, the government came to one of Audrey's hackathons and they said, please help us listen better. Oh God, please help us make sure this never happens again. And Audrey went from high school dropout, Silicon Valley entrepreneur, civic hacker, to being the digital minister of Taiwan. And as she's become digital minister of Taiwan, she's done something that no other politician in the world has currently done. She's began to transform the way that her democracy works. She calls it a mixed reality scale listening exercise. It's called VTaiwan. It's a kind of social media platform that looks nothing like Twitter, nothing like Facebook. It's all about gamifying consensus. That's the way they're trying to build it. But it brings tens of thousands of people all together to try and come up with consensuses on important questions for Taiwan. The first thing they did this on was Uber. Now, she is a completely new kind of politician. Someone that wants to change not what government does, but what government actually is. But she will not be the last. And for many people in this room that outlive people like me, like, you're going to have to change the way that democracy works. It has become quicker, it has become more digital. Everything else has changed in society now. We've all changed. And our democracy has to better reflect the way where people live, where they talk and how they want to engage in it. So maybe you'll become a hacker, maybe you'll become a citizen journalist, maybe you'll become a meme manager, maybe you'll become a gamer, maybe you'll become a digital democrat. But there are so many ways of transforming the world now through technology, ways which I don't think are well understood. But embracing tech, and reaching through it to change the world is now wide open. And there are just so many exciting ways in which that can be done.
All of this technology driven by mathematics and statistics predominantly, looking into things that, many people would say, great things to do. What about the confirmation bias that there is underpinning some of these things, where there's a different opinion from different people in different societies? That's what I'd like you to think of. Because with all technology comes responsibility. And it's important to understand that. And actually, as you are growing into your love of the sciences, technology, engineering, mathematics, you also need to grow your understanding of who you are within society and your responsibility to society and the planet. So with that, I bring you on to our final speaker, Professor Julie McCann. Julie works at Imperial College, where I work. Imperial College is supporting Collider Science considerably. And Julie, please.
Thank you very much. So one of the jobs you could have is what I'm called a computer scientist. So you're saying, Julie, what's a computer scientist? Well, I tend to answer a computer scientist is the same as a rocket scientist, only I replace the rocket with a computer. So that's what I do. Now, so what I'm going to show you today, hopefully to give you an idea of what I do, I'm going to present the sort of things that I think about. Because as a computer scientist or a professor, I imagine you think, oh, Julie just stands in school all day going blah, 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 blah. No, I have a different side to my job, and I want to present that as well to you to show that it's diverse and actually interesting. And then I will show you why it's important to understand the ethics behind the kind of work that I do. And then I'll show you some future stuff that hopefully entices you and gets you excited. Okay, so first things first. You know I'm a computer scientist, and you're saying, hey Julia, I know that you do computing, and I know what a computer is. Do you think you know what a computer is? Okay, these are the computers that I use. I'm going to show you exactly 2 examples. So this is a computer. This doesn't look like a laptop. this doesn't look like a PC to me. This is a computer, a full computer. See it? Has processor, has communications. It's got 2 sets of communications. It's a bit like your phone that way. There's not Wi-Fi, it's a thing like Wi-Fi, Bluetooth. It has about 5 sensors on it. It measures light, sound, movement, and so on. It's got lots of different sensors in it. And it sits around environments, keeping an eye on those environments, and allows me and other people to maintain them, and allows us to be able to predict any failure, like a road's going to break or a bridge going to break, moreover. And then we can either fix it in advance or indeed make sure that we build them properly in the first place, like engines and things like that. So we call these systems, these little computer systems, sensor devices or sensor nodes, and they all talk with each other and form a sensor network. One other application we can use these for is, for example, in Mars, we can use these as weather stations. These are little tiny sensor computers that also, there's 4 on this flippy floppy thing here, and these can be used to measure magnetism or solar wind and things like that out in space. So computing isn't just your laptop, computing isn't just your phone. It's many different things. Now here's the thing, is my job is mostly about problem solving. And I'll talk you through some of the kinds of problems that I solve. Now the first thing with these little computer systems, they're low powered, meaning they're based on batteries. They don't have an awful lot of processing resources, so your phone is like a supercomputer compared to these systems. And so we have to be able to make do with what we've got. Now, it turns out that bugs, fairly smart but not super smart compared to us. So what they have done is they've formed colonies to allow them as a species to maximize their chance of survival and reproduction. Funny enough, in our little computer systems, we borrow those same ideas, those same what's called emergent algorithmic ideas. And we allow those to run amongst the little computer systems. They all take on different roles, like the equivalent of one doing the communications and the other doing the comms, the processing. And they all have these different roles, and the network survives. Now, the one difference between these little systems and the physical real world, the bugs that I talked about, is that they can't really scurry around looking for food. So we get our energy in these kinds of systems from a number of sources, usually battery powered or harvested from the environment. And so to make better use of, to get the system to run so that it doesn't fail, it has to budget the energy coming in from that environment or from the battery, which means we have to optimize that, which means we have to make the best of it. And that's a set of mathematics. We were talking about maths as one of our subjects, and you can see a nice sort of equation there. So we do that sort of thing to try and maximize the lifetime and its ability to process. We have another challenge, is that these systems are out in our physical world. They're not sitting in a data center that's well controlled in terms of its atmosphere, let's say. Even your phone has an atmosphere that's better controlled than our systems. These systems also have to use wireless communications. Now, here's the nice thing about wireless communications. The air can only hold, so much wireless communications at one time. Now, if I have thousands of these little computers out there, they will all talk at the same time and nobody will hear them. So I have to work out different ways of allowing those systems to all talk, and your phone and the security systems and all those other big systems out there at the same time. One such way to do that is not to build yet another computer infrastructure or communications infrastructure, it's to borrow your mobile phone. So if you're walking across a park, my little sensor systems are out in the park and they're relaying the data, jumping through your mobile phone right back to me in Imperial. Some nice ethical issues there. Not only that, whoops, this has decided to have a life of its own, it must be haunted. Not only that, we try to incentivize you to use your phone to allow us to relay our data through your systems, and that turns out to be mathematical as well. So we use the maths of incentivization, which is also the maths of gaming and strategy and those kinds of things, to encourage people to use our phones. Now, why is this important? Well, we're seeing these kinds of systems across everywhere. You're starting to see them in your home a lot more now. You've got your nests, you've got everything. And it is haunted, absolutely haunted. Right. I could kill this, 1 second. Oh no, I've done it badly now. Anyway. Oh yes, here we go. I can fix this in 1 second, excuse me. Oh no, it's not the same slideshow. Here we go. This is what's wrong. Just if anybody ever has this problem themselves, they know how to fix it.
This is machine learning in action.
Right. What can you say? Good. Anyway, so you can see these systems in the real world out there, and you're starting to see them more and more. Usually because they're tiny, they're hidden, so you don't get to see them properly. But where I might tend to focus on what I call the sort of belt and braces end of the subject, I'm more interested where it's used out in the environment, like a big city and so on. So for example, you've got smart cars there. There's something like 60 sensor systems and processors in a normal car, never mind a smart car. You've got your smart grid. Smart grid is where you generate electricity from your house and feed it back into the grid. And for us to be able to do that in a nice clean way, we have to be able to understand what's going on into the grid, and we measure that using my kinds of systems and so on. So we have them out in the infrastructure around us. Other examples are in smart cities generally, where we're trying to make best use of our facilities, like our water networks or our transport networks, or to help blue-green the city. We have these systems out there bringing nutrients into the actual trees into the city, or bringing the water across the city in the same way we have the internet relaying data across the networks there. So we do all that kinds of things with these kinds of systems. Now, one of the ethical issues is that these kinds of systems are harder to keep secure than your standard phone even and your standard data center, because they're all in an environment that kind of locks them in relatively. These systems are small and don't have much room to do much extra processing from what their main job is, which means you can't put sophisticated security algorithms, security code on top of the actual code that's there. Furthermore, they have lots of different vulnerabilities that a data center wouldn't have, for example. So for example, I think yourself mentioned earlier about using sound to bring down a laptop. Oh my goodness, you can bring my system down with sound very easily with light, or you can just kick it. That works as well. Another thing we've got is what's called cyber-physical interaction. Cyber-physical interaction is where the computer system is controlling a physical system. The example we've got here is a water network. And the water network is supplying energy to the computer system because it's vibrating, and I'm getting the energy off that. Now the thing is, if one of those two systems fail, they all bring each other down. And I need to know why, and I need to be able to predict that, and there's no science right now to do that. So this is something you guys can help me with. And finally, I think I wanted to show you something quite cute. This is where I'm going with this, and it's got ethical issues as well. Let me see if we've got it here. Right, so I'm aiming to bring these systems down to super tiny sizes. You thought that machine was small. I've got a smaller one in my hand now. And this is what we call smart dust. And the aim of smart dust is to have these teeny tiny computer systems. I have 10,000 of them in my hand, and I say to my hand, I say, you form a pyramid and become a Wi-Fi router. And it can form that for me. Or you can change shape and still be a Wi-Fi router. Okay? And this is what I'm aiming towards. This is my crazy science. Now, we have some of this science existing so far, and in my hand, hopefully you'll see a little tiny machine, pretty much the same as the other one I showed you, but much, much more miniaturized. So, see this box? This box is massive. The little piece of dark in the corner of this box is the actual full computer. And at the end of this, you can have a look and see how tiny that is. I can get this much smaller. It's this size because I don't want to lose it. Now, you can imagine the ethical implications of this. What if this gets in your nose? What if this gets, I can sprinkle it all around here and watch what you lot are doing and you don't even know that I have that. Lots of ethical implications. So I want you to think about that. Oh. And these are them forming solid structures. And you can see they can get down to tiny sizes. Finally, I wanted to show you a little video of where we use these kinds of systems. You can see this is a very flippy floppy computer here. What we're hoping to do with these is we put them out on what's called a CubeSat, and the CubeSat goes up to space in a rocket, or it goes in your friend's pocket when she's out in space, and maybe she let go of you. Anyway, and what we do with these, we can place these in the what's called the CubeSat box, and it explodes them out, as you can see in that picture, and then they float down, and as they're floating down, they're relaying information back to us in the roof of Imperial. And this is one of the projects. The other project doesn't seem to want to show itself, but I'll describe it. The other project that I was going to show you was one that a robot sits over a canal and it builds a bridge over the canal. And it's building the bridge, it's printing the bridge, the metal bridge, and this is work we're doing with Turing Institute, and at the same time it's placing the sensors in the bridge at that time, relaying back the information from the robot and the bridge that's being built in 3D live, telling me how well that bridge is structured and how well it's going, and predict how well it's going to be able to hold people. And that's my talk.
About your age, typically, there's a film called The Fantastic Journey about a miniaturized submarine that went inside you. It was to cure a brain hemorrhage in the president so that he could make a big decision to stop blowing up the entire universe through thermonuclear war. And what Julie was talking about there reminded me of that, except for this is a reality. That was science fiction. You have to sort of remember that what you're seeing as science fiction now will be in your pocket in a few years' time, doing amazing things. But it'll only do that if people like you, people all around the world, innovate using science, technology, engineering, maths, growing your creativity through other things, reading, playing musical instruments, helping grow that sort of adoration of everything that's around you. But just remembering that nearly everything around you has been created through the use of science and technology. You know, new forms of construction. We used to build bridges with hundreds and hundreds of people and huge amounts of steel. Now we use a machine to actually build it in situ with all the things that it needs in it. So Julie, I'm going to ask you. You talked a lot about the ethical conundrums around some of these things. Who's looking into the ethical conundrums? That's one for you to think about. So we haven't got a huge amount of time. I'm sure you've all got lots and lots of questions. So my questions are going to wait to the end. What I'd like to do is invite you all to ask questions of the individual presenters. You've got their names in front of you in the little pamphlet that's there, or of the entire panel. Name your choice. So who's first? Who's going to ask the first question? So we have one lady back there. Fourth row back.
Hello. Okay. My question is for Carl. So I just want to know, you talk quite a lot about citizen journalism, and I want to know what are your thoughts on like social media sites like Twitter being used to sort of peddle fake news, and do you think it's realistic to sort of promote like censorship?
Oh God! I'll just speak. It's actually it's not just. I actually met a fake news merchant in Kosovo. He's a very charming guy. I actually kind of like grudgingly admired his enterprise, if not what he was actually doing. It's not just fake news, unfortunately. It's militaries around the world have essentially redefined warfare to be something that can be, it's weird, but it's true, that can be fought within the domain of information. So the first like fake network on Facebook, specifically targeting the UK, was discovered last week, and that was a series of accounts that seemed to be sitting on both ends of the political spectrum and kind of trying to stretch it apart, both sending hate and also calling out people for sending hate. It was very odd. The real difficulty, right, and I've spent time with the kind of like the teams in the tech giants that are trying to deal with this, is that most of this isn't actually fake. And most of this isn't actually pretending to be news. You can paint an incredibly distorted picture of the world simply through the judicious selection of facts, truths, but you just eliminate others. So there is, I think in each of our works we're pointing to areas where there's at least one Nobel Prize to be won. And there's definitely a Nobel Prize to be won in coming up with a kind of like a robust definition and response to the way in which social media platforms can kind of engineer and manipulate opinions, which both stops that, but also, as you said, kind of preserve the basic liberal values that we've got that basically allows, in most cases, people to say things even when it's an unpopular thing to say.
Brilliant. Anyone have anything to say about that?
It's a great question.
And next question.
I think you touched on it, Chair, when you asked Julie McCallum, who's responsible for the ethics? When you set out with your new invention, such as just talking about fake news, that runs ahead of the inventor. Who's the responsibility to chase after the ethics and chase after the difficulties initially before they develop into overwhelming us?
Well, I'll give a response to that, but everyone here could give their own response as well. One of the reasons why we need ethicists who are trained in maths, physics, chemistry, biology in particular, biochemistry, the STEM subjects, is that it's absolutely essential to have an understanding of the technologies and the sciences that underpin many of the innovations that come along. For example, 2008 there was a major financial crash around the world because of these things called collateralized debt options and obligations. And they're a mathematical and algorithmic determination of lending money and swapping debt, actually. Now, there's no one looking into the efficacy of this financial technology instrument. It's purely mathematically derived by people who in the city are called rocket scientists. They're actually called rocket scientists. They're PhD physicists like me. In fact, I nearly became one, but I actually thought ethically it was entirely wrong to do that sort of thing. If there had been more ethicists who were trained mathematicians and statisticians overseeing that side of financial technology in the first place, maybe we wouldn't have had that crash. I think who is overlooking that? The people in this room are going to become the people considering their responsible innovation around what they're doing, the ethics around what they're doing, because it hasn't really happened in the past. And technology has always been 5 steps ahead of the law. And that's why we need a new form of digital law. That's why we need a new form of digital ethics and efficacy around, for example, decoding the human genome. Who's to say that it's right? You know, in terms of what ones and zeros are representing what GAs, Ts and Cs in your DNA structure. And who's to say it's been copied or not been copied, or bits of it being copied? A whole new realm of technology ethics is out there waiting for you to discover. So,
I just wanted to add to this a recommended book by an author called Yuval Noah Harari. It's called Homo Deus, and it talks a lot about the ethical implications of technologies that are making us smarter, healthier, genetically engineering, humans, and this is one person who is bringing up those ethical issues. He's not going to be the one responsible per se. You would expect government to be responsible for those ethical issues in terms of regulations. Now the technology is evolving so fast that not always governments are able to keep up with it. And for some things, like let's say blockchain, for example, that came out like a storm. Some governments reacted quickly, they put in legislation, and then you provided an environment for people to make use of this. Now, some governments just ban it outright, and some governments just say, look, this isn't going to happen, we've got bigger issues to solve right now. So, you would hope that governments regulate those things, but not necessarily. Don't put all your eggs on the government, all your eggs in one basket on the government. So there's another route for academics to talk about those ethical issues, or in non-invasive brain stimulation, for example. One of the top names in the UK have published a guidance for European Union, and then all the scientists across the globe in the field have gathered up to publish a paper where they discussed also the ethical, the safety considerations, the ethical considerations, and the protocols for doing this kind of thing. So, and then finally, I think something that's within your control is the market force. In a capitalist environment, this is a huge, ethical force. So, I mean, if you think that, farming inorganic and farming unsustainable is a non-ethical manner, then you have the choice to actually make this put this to be ethically correct, and stop buying particular force, and stop buying particular kinds of meat or chicken or whatever. So that way you are the ones who are responsible for the ethical implications of the technologies that are coming out.
I can just speak briefly to that. So I got very close to the Cambridge Analytica scandal, very close. And I had to use my moral compass as a data scientist to find my own way and use data in a very different way. And for example, now I'm doing some acoustic therapy where we use ultra-audible signals that you can't hear, but could have a very bad impact on the brain, and it's silence, so no one really knows it's there. But the ethics has to be first. So we're placing limits on every single thing that we do, and the ethics dictates how we move forward, because it's very easy to see how lots of tools can be used for bad before good. And so I think it's important for data scientists to lead this by example and to speak loudly about this. I found my voice through experiences, and for other data scientists to just collectively grow their voice. The ethics isn't a barrier, ethics is the lead, and it should be the first step in everything that we do. We need to see 500 years into the future when we think about our work, so I think it's very important. And then just a quick related point is that we need ethical entrepreneurs and responsible impact. So again, I've seen myself arguing with investors asking for less money when they offered ring-fenced more. And it's a very counterintuitive experience, but I want it for a different purpose. I want it to serve a more culturally sensitive purpose, or it to be feasible in low and middle income countries. So I'm asking for less money, but for different purposes. So I just think scientists have an opportunity to think differently and to try and voice in the real world, get out there and get their knowledge to start working with the real sectors and changing things.
So let's ask another question from the floor. There was one lady over here. There?
Yes. My question was for Becky Inkster. You talked about analysing language in music and using that to kind of protect vulnerable people. You mentioned that. So how are you using what you learned from that data to protect people?
That's a great question. So many things. Okay, with music, let me take a different example actually. I'm going to take an example of financial health, because music's a bit intuitive. So when we look at people's data and their financial situation, you can start to work with them to turn things around, the way they speak about their debt or their situation. And again, this can be seen in music, but I just want to try change the example slightly. And you can start to use things that will predict what they might say next, and help them to redirect their thinking. And so debt is a very strong predictor of suicidal thoughts and lots of other mental health related things. So when we start to see initial red flags in the data, and this could be going back to music, I do something where it's like a rap bot, where people can enter the freestyle. So this is verbal dexterity, this is neuroscience in very uninhibited kind of ways. But again, we can look at their data, and verbal dexterity is a protective factor against psychosis and many other sort of mental health things that we worry about. So once you know what people are saying, and music is just such a great way to unlock it, but again, looking at financial situations and things like that, all kinds of data, you can start to not nudge, because I don't like that word, but you can redirect people and bring awareness to their situation through their own data, through their own words, and start to change their paths, either through recovery or making better financial decisions or getting support when they need it, when they're through a challenge and vulnerable. So I hope I can always discuss that in more detail after.
Yeah, of course, there will be some time afterwards to speak with any of the speakers.
I suppose, sorry, just to say quickly, vulnerable to me, it doesn't mean just someone who is at the low end of poverty. Vulnerable is a lot of people, 1 in 4 people struggle with depression, and this is across socioeconomic classes. Okay, so this is a huge problem everywhere, especially with financial health. Gambling and these types of issues impacts a lot of people across the spectrum of society. So vulnerable is a very diverse term as well.
So, more questions, please. Yes, young man.
My question is for Caroline Leroy, and I'm wondering whether, obviously obesity is becoming an increasingly bigger problem across the globe, and I'm wondering whether our gut flora and our microbiome could possibly be used to solve the crisis, and whether it is linked to it, and whether other people, or some people could have a predisposition to it due to the bacteria that live in the gut.
Okay, so obesity is linked to the gut microbiome, so there are a lot of research that have been done to show that indeed people who are obese have a different gut microbiome, and then that has been turned into animal model where they show that by giving a certain gut microbiome to an animal, you can make it obese. So we know that there is a link, there is a causal link. You see in human, the ethic makes it much more complicated to work on that. You're not going to ask people to take a microbe to check if they become obese or not. There's been some work that has been done to kind of reverse what is observed with obesity, and is slowly developing with doing fecal transplant, which obviously ethically is very complicated as well, because the gut microbiome, we know very little about it, and there are a lot of data, and giving something that is so complex to someone without knowing what exactly it does becomes very complicated. So it's very at an early stage, but we have very positive results in that sense. So you can reverse. I don't think it's a solution, because I think obesity is a multifactorial disease, so there are many things that come into consideration. Obviously diet is one of them, physical activity, but the gut microbiome definitely needs to be regarded as an important player in the development of the disease, and should be considered when looking at therapies at least.
Yeah. Great question, by the way. I'm fascinated by the microbiome. I'm particularly fascinated by the old adages. You know, things like you are what you eat. We know the gut is linked, and the microbiome is linked to our brain in particular. So the relationship between microbiome and obesity being looked at, obesity and mental health perhaps.
Also, the microbiome is being used linked to aging as well, as an anti-aging strategy. So it's got many uses.
So many fascinating areas to get involved in. I just don't think quite got enough time to get into them myself, but you all have. So, more questions? Whoever you saw first?
Who was it?
There's a chap here.
Oh.
Just to your left.
To each of you, in your respective fields, what influences your decision to make a sacrifice in an advancement for the sake of ethics and the pursuit of ethics?
Well, there's a challenging question.
I can answer that with a concrete example. I don't do any defence research, and I could absolutely have an absolute fortune of research funding if I went down the defence route. It's that simple. You just say, no, I won't do defence. Because you can imagine these sprinkled out, monitoring people, sending signals to people. Yeah, I don't want to be associated with that. I'd rather be without research funding than be associated with that.
But even in that situation, if you're not directly involved with the development of something which could then be used to harm or monitor people when they're unaware of it, and how do you avoid developing something that if you know, for example, if there's industrial espionage, that then if it does become, well, that is then stolen, how do you draw the line there?
It doesn't even have to be stolen. Most research scientists publish their work in the open domain, so you can see that our hardware, you can see our software, so to a certain degree out on those papers. So a naughty person could do the very same thing and replicate what we're doing and use it for a less positive reason. Most of my work is still lovely and so on. So there's nothing I can do much about that other than be on top of it and be on top of the system, because I know their system. So I can counter that system, I can make systems that can counter those systems. So I know exactly what other people have done if they've taken the type of system that I'm using. And also, I mean, that's a kind of out of our control, but there's an awful lot of control. I mean, we've got, it's kind of answering the question you've allocated to me, we've an awful lot of checks and balances within the infrastructures that we work, in the university, in the funding bodies, in our governments, in our colleagues, in the people walking down the street. You know, we have to, we get lots of people questioning us constantly. I'm here being questioned tonight. You know, these things do exist, and we do keep an eye on each other and call it out when it doesn't look quite right as well.
I wrote a whole book on this, so I thought I would jump in about the ethics of technology. I mean, like, so technology almost always is used for both good and bad things and can be used for good and bad things. But the people that are going to employ it in ways which are nefarious are never going to be sat in front of you on a stage. But the kind of like the really kind of like worrying trend, I think, is that kind of people are using tech to kind of change society without ever like making the argument or having a discussion about why society should be changed. So if you go to like blockchain communes that are kind of breathlessly building various kinds of Bitcoin kind of variants or cryptocurrency variants to undermine states, like they see a future where states are diminished and they want to use technology to get there, then they're not making the argument. If you look at, say, information warfare brigades, which are going to increasingly be targeting everyone to try and change the way that they think, again, they're building technology to try and make that easier, and then there's no kind of public argument, there's no court system, there's no legal dispute about whether that's a right or wrong thing. In general, I don't want to kind of alarm too many people about this, but I think it is an important thing that we have to confront. I see the kind of general rules-based order like breaking down quite quickly. We've always tried to kind of cage, say, power, the ability to, say, change society. We've always tried to cage that. We've always tried to surround that with laws and regulations and professional standards and public scrutiny. And almost any way you look now, it's actually breaking out of those cages. The ethics are biting less, the laws are less well enforced or more absent. The professional standards are far less present. Like it's in so many different areas, kind of technology is causing new concentrations of power which are far less controlled. And really the one I should have added, I know I kind of listed a series of kind of tech jobs for you. The one that's really important is the unspoken one, number 6, which is how do we get all the squishy human stuff, you know, the ethics and responsibilities and the public scrutiny, public awareness about what this can do. How do we get them to start moving as fast as the tech itself? That is a huge, huge, huge problem.
Brilliant. Anyone else anything else to say? I think that's actually said it all. I think that point 6 that you made, Carl, about how do we get people up to speed on technology and reverse this years-old trend. You know, it takes 5 years to put a law through Parliament. 5 years. I saw someone actually innovate something around a cryptocurrency. It took him a day and a half. You know? No thought to the ethics behind it. You know, cryptocurrencies use a huge amount of electricity, enormous amount. I believe data is the new plastic, you know, think on that one. But the only way we're going to get people ahead of the game on this is through people studying the sciences and technology, engineering, mathematics, their use in games, gaming, digital developments, and really understanding it and really getting to grips with it so they can start suggesting the checks and balances that should be in place, thinking in advance. As Carl said, you know, thinking about the issue before the issue arises.
And actually thinking about new ways that the rules and laws and norms and ethics actually can bite, right? So like regulations and laws, these are not the ways in which technology are going to be controlled. No. So it needs to be technologists that are designing the kind of basic principles and decisions about what we want the tech to do actually into the tech. Like ethics by design, that's going to have to be the way that we go. Yeah. You know, or Royal College of Algorithmists, you know, like new groups that bring together technologists to actually watch each other.
Let's have a government ethicist and a government digital ethicist who actually start to at least expose our MPs to this sort of thing. They're not going to come out of people like me, or possibly people like Carl, but actually it's going to take highly trained, highly skilled, younger people to do this. So, more questions. I'm sure there are more.
Got one here, and then there's one there.
Okay.
You mentioned about the guy who bought an asteroid in the virtual game. And do you ever think that virtual reality, with it being on the rise, can ever become a substitute for real reality?
It's a brilliant question. For many people, it already is. I mean, like, if you want to talk about the kind of, if you want to talk about meaningful social relationships or friends, or like the reasons people get up in the morning, or the relationships that they cherish, or like kind of how they learn about the world, it already has substituted it. One couple that I didn't mention before is Jem and Gina. So Jem and Gina, the first time they ever met face to face, there was a BBC camera there filming it. They'd been friends for 7 years before they'd ever met. They met on a Facebook group dedicated to getting through grievance and loss. Jem was going through financial hardship at the same moment, and she woke up one morning and Gina had bought a washing machine that was there on her front doorstep. They'd never met in real life. So in one sense, already it really is. I mean, people hold wakes, they hold funerals, they kind of gather in virtual spaces to kind of remember departed friends. And of course, like, it can be equally as harrowing. I mean, cyberbullying is just as bad as bullying. It's just another kind of bullying. So this kind of divide between the real and the digital, or the real and the virtual, I think is getting blurrier and blurrier all the time. You know, there's the hikikomori people that I met in South Korea. These are people that only live their lives online. They never leave their house. For them, that is their world. But of course, yeah, I mean, of course, virtual reality as a kind of wraparound kind of sensory experience is, I mean, for those who haven't done it, it's unbelievable. Already unbelievable and rushing forwards. I'm actually pretty worried by this. I think we're going to lose a lot of people to forms of realities which they can shape themselves. I don't think it's necessarily a good thing. Probably just another area where you know, the onset and onrush of technology is kind of throwing up like issues so unbelievably thorny, we haven't really begun to think through how to ethically navigate them. But there's nothing that we can do to slow it all down. We can't slow down technology, and we don't know how to speed up ethics yet. That's the Nobel Prize, by the way. Anyone who makes the ethics go as fast as tech, that's the, you know, this school will be named after them after they've managed to do that.
I actually wanted to bring up a question in relation to your question is, what is reality? Why do we, you know, we still don't know what consciousness is. And no neuroscientist would be able to give you, I'm wrong, no, you can give an answer to what a consciousness is, but, you know, how is it that there is a reality that you go to sleep, that reality goes out of the window, you're in something completely different, then you wake up the next morning, you're back into reality. So, you know, the virtual reality is that another step forward. Yeah, that's going to be less real by today's standards, but you know, once we start finding out more about consciousness, we are bound and start playing around with it. We are bound to, you know, enter into different states. So, you know, the question is, what is reality?
And of course, your reality isn't the same as my reality, so you're my version of reality. True. So there's a question over here, and a question with the lady over there.
So this is in relation to the microbiome, and I was wondering, have any specific conditions been linked with specific bacteria, and what strategies are being developed to deal with them?
Okay, so there are many conditions that have been linked to the gut microbiome. I think probably too many actually. So we start to be questioned about what is right and what is wrong. In terms of specific bacteria, there are as well, and but the problem is, in terms of biological science, it's a struggle at the moment with the technology. We have to have a lot of data to make sure that it's actually true. So what we do need to be validated in different populations. I work with one cohort, and we always try to replicate that in other cohorts in other countries to make sure that all result is actually replicable, and we're not saying something that is just by chance, because by manipulating data, you can do a bit what you want, and sometimes you just create artifacts that are not true results. So you always need to be very careful about that before you move forward. And there are lots of companies, and biotech companies are created to try to deal with creating new solutions and bring to the market bacteria that can be used as drugs. The problem is that at the moment in Europe at least, we are in a very grey area where we don't know if it's a drug, if it's a food, and legally it's not defined at all. So it's very complicated to actually work with that, because as it's not described as a drug, you cannot commercialize it like that, but you don't know either what you need to prove before creating a product in terms of trials to be able to bring it to the market. So there are a lot of things moving forward, but there is not really anything yet that can be called a drug. So far it's what you can buy on the supermarket, like Yakult or things like that, which is not a drug, that's not curing anything, it's just maybe improving a bit your gut microbiome if it works for you, which might not be the case for everyone as well. So there are things coming, and it's actually a lot of people asking me why we know that the gut microbiome is so important and nothing is done about it, but because legally it's not defined, first of all, so we don't know where we're moving, but it also is very important to have it defined, because we don't know what we're playing with, because we don't understand it. I've been working on this field for many years now, and I cannot tell you with certainty anything, because it's a very complex system. So it's quite complicated, I would say.
I had my
a great question.
microbiome analysed by one of the commercial companies, and the results came back about what gut flora I had. It said specifically I had no gut flora that enabled me to absorb pantothenic acid, B5. So I'm taking a food supplement of B5. Most of the drugs are actually supplements. It's made a difference. It's a bit of a coarse experiment, but it's interesting. Very interesting, relatively new field, actually, that needs a lot of deep science, actually. So, there is a lady over there, and there's a lady here and a lady there.
Hi. So I go to a lot of these fascinating talks, and I'm just a layman, but I'm interested in science, and they're extremely bright, extremely creative, extremely well educated. But what I've gathered through the talks that I've been to, it seems like to me the three most pressing issues facing humanity are: number one, global warming; number two, from a pharmaceutical point of view, the instinctness of basically the ineffectiveness of the current antibiotics, and then something that's man-made is that society will change extremely, like in a worrying way for governments when artificial intelligence takes over a lot of human jobs. So what will the governments do to help the unemployed, for example? So from my perspective, with all of these other great things that you guys are doing, like I went to one talk with a neuroscientist is trying to figure out how to commercialize dreams, and you can actually order the kind of dream that you want to have that night, like you would a movie, and pay for the service. So I look at these great, fascinating minds.
What service is that?
ordering dreams on, like, what dream you're going to have.
Yeah.
So
What's it called?
It's
control my dream.
So basically, it has to do with connecting the, what one of the gentlemen was saying, connecting probes to your head, and then being able to program what kind of dream you're going to have that night. So, but my question is, with all of you amazingly smart people doing these great things, that ultimately the human population gets wiped out, like a third of us, because of extinction of antibiotics and us not being able to fight some simple virus or bacteria, and then or global warming, where you hear all kinds of end of the world kind of stories. Wouldn't it make sense if more of these great minds kind of looked at these bigger picture issues, to target that first, and then look at the more fascinating, creative, fun things, for example? Or does the scientist not really, or when you're doing your fascinating work and you're so passionate about it, do you not actually worry about the other stuff?
On the contrary, that's the essence of what we're doing as scientists, I think all around the world, is that we're trying to solve global challenges, the big challenges. So, antibiotics. The big problem with antibiotics is 80% of all the world's antibiotic use is in livestock. It's in your fish, it's in your seafood, it's in your meat that you eat. So, you want to cure the antibiotics problem? Stop eating meat. That also helps global climate change in a big way. So, scientists have determined that actually the key things are not to produce better antibiotics, it's actually to use a lot less of them in our food. Food has all sorts of connotations. The dreams thing, really interesting. Wim Wenders, a famous Dutch filmmaker, back in 1991 produced a film called Until the End of the World, where you could record your dreams and replay them onto someone else. So you could actually exchange dreams. Science fiction will become science fact. People are doing these sorts of things. What's wrong with it, really? To be able to control your own dreams so children never have nightmares. Abuse victims can never relive through dreaming some of these things. That could be a really positive one. Climate change, I mean, there must be 1 million people around the world in science working on climate change. Or actually, climate change happens. The planet has had it happen for years. What we're concerned about is the destruction of humankind through our addition to climate change because of our, in my view, addiction to electricity. So people are looking at new ways of better energy efficiency for the new technology, as Julie mentioned, around energy scavenging, energy harvesting at very low levels from stuff that's all around us already to power some of the devices. I think scientists are really looking into these things.
Yeah, I think on the surface I look like a computer scientist, but the truth is every single one of the applications of those tiny machines are sustainability based. I'll give you an example, a very concrete example. So if we all went off our meat, we still have to eat something. And if the population grows at the rate it's growing, by 2050 we don't have enough arable land on this planet to feed everyone, right? So what we're doing is we're looking at how we can do that. One way to do that is to make the best of the land that we do have. But you have to remember, if you overgrow things in the land itself, that you can have too much feed in that soil, you can ruin the soil and so on. You put these little sensor systems in with automatic controllers, and this is a positive part of AI. The system itself is able to determine what that plant, as an individual plant in a space and time, given the weather, needs, and just its bare minimum needs to be able to produce the food that's needed. This has nothing to do with, this could be organic, it's nothing to do with anything to do with genetics. And as a result, you get more from that land without destroying it. That's one example. As you mentioned, I mentioned earlier smart grid. Smart grid is a way of trying to get energy in a more distributed way instead of using our big coal plants and so on. So it's using solar on your roofs and things like that. Most of us are working in some way to contribute to the big problem. You know, not to contribute to the problem, but probably doing that as well. But to try and counter some of those problems. But you have to remember, scientists are human. We're human. We don't all have all the big, sustainability head, talents. Some of us have talents in other areas. And it's not just science, we need the arts as well. What a dull life we would have if we didn't have creativity in the arts.
I felt very guilty for not being a climate scientist about that. But no, I mean, it opens actually an important point about careers and decisions, which we haven't actually spoken much about our kind of backgrounds and where we find ourselves are. But I think to say that the kind of researchers in general kind of probably sit there at one point at the beginning of their careers and try and weigh up kind of global issues and try and work out which should be a priority for them probably isn't the way that they or human beings really work. I mean, like the routes into jobs that tend to be like much more opportunistic. You kind of like leap from thing to thing that you find interesting. I mean, for instance, like the whole reason that I study the internet is because in 2010 I'd been in the Foreign Office and then I'd been an academic, and I wrote a pamphlet that basically said all terrorists are conspiracy theorists. The conspiracy theory community thought I said all conspiracy theorists are terrorists. They mobilised like a swarm of angry bees on the internet, and I suddenly wondered why I was being totally outmanoeuvred every time I looked by this kind of online community, and it got me fascinated in how this is pre-social media, really 2010, so pre-Twitter. I was really fascinated in all these new groups that were forming online. And I'm sure that everyone around this table probably has like similar experiences where they kind of knocked from thing to thing. So it's difficult to look back for me and to think of a single moment where I ever weighed up global challenges and thought the internet was going to be the one that I dealt with. I think like many other professional paths, like you kind of look at the opportunities you're presented with and go for one that sounds interesting.
Or create the one that you want. So I went into engineering biology because actually it can solve some big global challenges. And I thought, well, hey, that's really funky. I want to do that. So I did it.
I just wanted to argue that I'm biased here, but I think mental health, that's the global challenge. And I'm thinking that, when I was like demonstrating in the conferences, kind of caps with electrodes, I couldn't help but think, what if, people at the very, very top power, at the very, very top of the power ladder, could be wearing caps that could make him or her. Actually, I wasn't actually sure whether I'm going to make it more politically correct or politically incorrect. So they can make people in power, smarter, more responsible for the kind of actions that they do. And it's like throughout, for every single person, we're all different. Everybody has, everybody's brain is special in a way. There are some severe cases. There are some, where people are locked in. This kind of the power to solve some of the challenges that you're talking about is locked in somebody who isn't able to communicate, and then through brain-computer interfaces, we're actually able to change that. So, I think once we've solved mental health issues, everything else will be solved.
Becky,
I agree with that, and I've done mental health for 20 years now, and I knew it was my career because I care about people. I used to line up my stuffed animals, and when one got hurt, I had a debriefing in advance, and I said, okay, they're injured, this is major, let's discuss any questions. So yeah, it was game on for me with mental health. But with childhood adversity and early life experiences, 1 in 2 children on average experience something that they then carry with them for their lives. So it's everywhere. And as I mentioned before, 1 in 4 the depression statistic that goes around quite regularly. Mental health is everywhere. We put on a brave face, we don't always talk about it because there's a lot of stigma, and I got my jewelry stigma, but it is, I think, one of the global challenges, and that we need to talk about mental health, we need to do more things about mental health. There are so many issues in that space, and lots of different types of scientists that can contribute to that in many ways.
Tina, there was a lady down here, and there's Jen, and another one here. So let's go for the two ladies here. Let's take.
So 10 minutes left. So
Yeah. So let's take two questions.
So which one do I go first?
So the two ladies here.
My question was for Caroline, and you mentioned that people that travel more tend to contain more antibiotic-resistant bacteria in their gut microgenome. So I was just wondering why that was, and if there's any application for using that into discovering the extent of the antibiotic resistance issue, which is obviously quite big at the moment.
Okay, so hold that thought. Let's have the next question as well, so we can take a few.
My question was also for Caroline, and it was, do you think we're at a point where you can transplant the gut microbiome to be used to treat bacterial infection and disease?
Brilliant. And let's have this chap down here and that lady there. We'll take 4 questions.
Hi, sorry, I also have a question for Caroline. It's about obesity and the gut microbiome. And I think there's been research carried about the firm cuties and bacterial disease ratio. And there's been research saying, like by Ruth Lee, saying that it's justified. But then there's also research also saying it's not justified. So there's been a controversy on this ratio. So I was wondering what you thought about it.
And then this chap here. So 3 questions for Caroline. So.
Yeah, Carl, I was just wondering, how do you think that the face of the defence industry and warfare in the future, would you think there'll be an almost complete paradigm shift in how warfare is, and do you think intelligence will become the new boots on the ground within the next 50 years, or, yeah?
Well, there's a whole evening in itself. So, we'll start off with Caroline, because I think you can probably answer those 3 in one nice long sentence.
Yeah. I try to be fast. Okay, for the antibiotic resistance genes in the gut, basically I worked on this project where we were trying to understand which environmental factors were responsible for, could tell us which antibiotic gene you're more likely to carry. And the idea behind that is to try to set that into the personalized medicine context, where a patient comes to an hospital and by knowing his history, we can say if he's more likely or not to be resistant to an antibiotic, and therefore we can approach them with a different treatment, or maybe find something else to try to cure them. So that's why it's important. I think just the traveling stories, because if you go abroad, you would eat different food, and as we know, when we go in certain countries, we are more likely to have diarrhea, which we treat with antibiotics. So there, from that, you get antibiotic genes in your gut microbiome. The second question was about obesity and there was a Firmicutes and bacteriolitase ratio that I remember. And the problem with what we're doing is that we have many papers that come all the time and they all say different stories. So I think we just need more research. Like, the problem in the field, the big problem we have is that we don't have an agreement among scientists on how we do research, how we do our statistics, how we do our analysis. So everything becomes very complicated. I don't want to say that you shouldn't trust anything that comes out in the news, but we are still at such an early stage that anything that comes out could be debatable anyway. So I think a lot more research and agreement globally around the world between scientists needs to be made, that we can agree on specific things to try to do that for us. And then there was something about fecal transplant. If we were at a stage that we can say it's safe or not, I would say no, we are not at this stage. However, we know that there are some diseases that are very complicated to treat in relation with antibiotic resistance, actually. People go to the hospital, they have a disease, and they get infected by antibiotic-resistant bacteria, and we can't cure them. And one of the responses is that, and I think it's great, and because it's the only thing we have, we should use it. However, as I say, we're working with something we don't understand, and when I compare that, for instance, with blood transplant, which is, I think, something a bit more simple and a bit more under control, we still had huge problem with that legally. So I believe that at some point we might face that as well with the gut microbiome, which makes it complicated for the moment. So I don't think it's 100% safe, but sometimes it's necessary, and if it's necessary, then it's probably good to use in some cases.
Does that answer your questions, do you think? Yep, great. So, Carl, warfare.
All right, the future of war. All right, so you asked, is intelligence going to be the kind of next big thing? And actually, it was the last big thing. So we lived through one revolution in military affairs that's kind of just happened, and that was all about, basically, we've got precision weapons. As long as we can throw a kind of perceptual field over a battlefield, we'll know exactly where to put them. So the last one was all about basically missiles and sensors and force projection and all that kind of stuff. And you know, this the last Gulf War essentially was the kind of manifestation of that. The next one, I think, is very likely to be, and it's happening now, is very likely to be about hybridization of war, hybrid warfare. So what we're seeing happening now is actually like a series of definitions of what warfare actually is, all being blurred at the same moment. And there's lots of adversary countries that have started to do this. So we don't quite know what is war and what is peace. We don't know what a military looks like anymore, and written explicitly in Russian military doctrine is the idea that it could be a biker gang, it could be an NGO, it could be a humanitarian mission, or it could be a kinetic military. The point of all of this is that militaries have begun to basically see behavioural change as their aim, and they can see that there's loads of different levers which they might pull to get that to happen, of which kind of violence is only one. So there's loads of blurrings happening. Part of the kind of hybridization of warfare, I think, is its extension into new theatres of war. So I mentioned information. So you've got air, sea, land, space. Information, and that's not using information in war. I just want to underline this. It's actually information being war being fought in information. So information maneuver, information dominance, mimetic weaponry, that kind of thing. The last theatre, I think, is probably the most sinister, because it's the one that's in all of us. It's cognitive, and this is like the one that militaries, I think, are extending into now, which is uses all the others, especially information, and it's basically about how to manipulate your view of the world to a sufficient degree to get you to do the behaviour which a military's kind of like, you know, overall strategy, foreign policy and so on, and wants you to do. So hybridisation.
Cool. Well, maybe not cool.
So the last point, just want to say in my defense, we don't do military applications.
So, can we have one last question? Because there's a chap down there.
One more question?
Yeah. Just, yeah,
So if the government were to implement legislation that enforced ethicality in innovation, what would be there in place to prevent firms from moving to a country that was uncooperative and was ready to weaponize technology for the worse?
Well, I'll give a brief answer to that, because I actually work in government some of the time on exactly that. And that's why, actually, for years and years, we've been making the UK a great place to do business. Better to stay here, you can do better here, you have more freedoms here, in order to enable perhaps more regulation and control, and at least knowledge of what's happening. But in my view, there's nothing to stop innovation from going wherever it feels it has a home. And most people innovate for profit, so fair question. Come on, Nikolai, you know, what stops you from going to the States?
Or China. Well, I mean, you're right, absolutely right. I mean, that's where the opportunity is. If we're submitting an application to Y Combinator, it's like an accelerator in the Silicon Valley. If we get accepted, yeah. If you get accepted by Y Combinator, you take it. If you get an offer from Stanford, you take it.
Yeah.
So with China, so we submitted another application to an accelerator that basically you spend a week in China, in Shenzhen, like that's part of the program where you would, you do the manufacturing. I don't see, I'm more of a globalist type. I don't see the borders so much. I think I sort of think maybe further. People sometimes call me "What's home?" because I was born in Russia, but I've spent more than half of my life here, and people ask me whether I miss home. I think the planet is my home. The way things are going with interplanetary travel being sort of in the headlines. If I was on Mars, I would miss Earth. I would call Earth my home. I'd call this planet without borders my home.
Yeah, without a doubt. I think on that note, it's time to say thank you very much to our speakers. We hope that we've stimulated your curiosity about the sciences, the technologies, the engineering and mathematics that underpin pretty much everything that happens all around us, and some thoughts around the responsibility that we all carry when we develop these things. Thank you.
Thank you to everybody and a safe journey home.
I've had a long and tortuous journey to get to where I am today. Currently, I'm Commercial Director at Imperial College London, helping to start up new businesses in new biotechnology. The engineering of biology to do useful things and make useful stuff to heal us, feed us, fuel us and sustain us, is how I describe it. I started out as a physicist and mathematician. I also studied psychology. I like to do lots of different things. I did a PhD in nuclear physics and semiconductor theory. I worked for the gas board designing sensors for the smart meter. I invented a new technology to make lab-grown diamond for De Beers and Anglo American. I've worked for a trade association manufacturing technologies. I've worked for government, deciding or helping them to decide which new technologies to invest in. Part of that was the understanding that a new disruptive technology called synthetic biology, deep digitized biology, could actually solve many of the challenges that the planet faces at the moment. And so that's what I've been working on for the last 6 or so years. There has never been a better time for people to embrace studying, learning, understanding, being curious about science, technology, engineering and mathematics, the STEM subjects. We are faced with global challenges, and those challenges are most likely going to be solved by a combination of STEM subjects with an ethical approach and understanding. So there's a requirement for ethicists in science and technology, as well as just the science, technology, engineering and mathematical understanding about a responsible innovation that can lead us to help bigger problems such as climate change. An example, new technologies to create new ways of creating the electricity that we demand, that we're addicted to, that aren't so detrimental to the planet. So there are plenty of big challenges, and now has never been a better time than to start a new business, and there's never been a better cohort of intelligent, sparky, dedicated young people looking into science, technology, engineering and mathematics. Curiosity is where Collider Science really makes a difference. And the only way we can really satiate, or in fact grow our curiosity, is by asking questions of everything. You know, man since the beginning of time has wondered why we're here. That's a curiosity, and we've used science, technology, engineering, mathematics, philosophy, and everything around us to describe where we are in a hopeful understanding of why we're here and how we can remain here and stay here. Kaleidoscience and science question time around that helps build that curiosity in everyone. Parents of children who often think, hey, you know, you should do music because you're good at music now. Perhaps them understanding that they can do that as well, and it can all form part of the rich mix that Kaleidoscience can bring to curiosity and creativity. Diversity is important in STEM subjects, it's important in every subject, it's important in the world. We're a diverse world. You know, why shouldn't we have a diverse approach to our understanding, love, curiosity around the sciences, technology, engineering, and mathematics? You know, one of the greatest scientists of all the world was Marie Curie. You know, 2 Nobel Prizes in different fields. Wow! You know, it's not about whether you're a man or a woman or, you know, diversity in that sense. It's diversity of thinking that we want. And thinking comes from everybody at all different levels. So it's not an exclusive area. That's why it's important.
He's a natural, isn't he?
I think I can compare it to when I was growing up and the opportunities weren't really there, because I wish they were. It's so exciting. You can look at anything from music, poetry, you know, outer space. You can look at inside prisons. The ability to use technology is universal, like many types of cultures. So I think that if you have a passion and you want to use any of the STEM subjects, it's now is the best time, more than ever, to actually try and do that. So you can bring creativity to those subjects and just bring them alive and make it your own. So every single conversation that I have, I listen and I take something from it. I work in mental health, so listening to everyone's story, everyone's narrative, everyone's experiences is very important. So sometimes the biggest things that I learn about or have those eureka moments come from conversations with people at a bus stop or conversations in unlikely places. So I get inspiration from every single conversation when I meet people and I talk to people. Obviously there are big inspirations that motivate me. I'm passionate about hip hop and the ability just to overcome obstacles and barriers, and I love that sort of the style of never give up and the underdog. So there are many sort of personal ones, but I would say, given my experience in mental health, it is literally that. It's the conversations I have with everyday people that inspires me to think differently about how I do my science and how I try and come up with solutions that best serve people. So if that makes sense, I think that's what fits right with my research. It's everything from biotechnology to music, neuroscience interventions. So really looking at working with disadvantaged groups as well, or people who are underserved, to bring equitable services in mental health and a more kind of holistic perspective on mental health. So because mental health is such a people-based subject, we have to look in diverse settings and go to diverse places to find the data, to actually find out what technology will best suit the circumstances and help the people. So whether it be prisoners transitioning back into society, whether it be astronauts who are re-entering the planet and need virtual reality to help reorient their brains to walk again. But it's really, all of my different projects are, I would say, mental health, innovation, biotechnology, artificial intelligence, and not neglecting the arts by any means, so creative ways of actually engaging with people, whether that be recording in the hip-hop kind of the recording studio or the booth as we call it, because that's what brings out the passion, and that's what we want to measure. We don't want people in a clinical little setting where they feel intimidated or detached. We want to have people thriving, and so we can measure changes and understand what treatments might really help them recover or thrive. A wide range of things. A big one is follow your own dream and follow your own passion, and don't feel pressured to have to tick any boxes for anyone. Don't aspire to be a professor. Aspire to create change or do good or serve the public and society. I think once you set the goals on something to give back rather than inwards and publications, and I'm speaking as an academic here, once you sort of reroute your thinking into the greater good and not worry about competition or how people how it all works behind the scenes. Just focus on trying to do good and to serve society. I think that's been the biggest thing. Don't put pressure, don't look inwards too much to try and tick boxes to aspire to be a professor, etc. I've turned down associate professor jobs, which people thought was very strange, but it opens doors when you really listen to yourself and what you really want to do. So be brave and don't think that you have to follow external standards, create your own standards.
Excellent. Wonderful.
Great.
Thank you.
I think it's absolutely fascinating field, whatever path they go to. There is more depth than they learn at school, and then there's a lot of applications that are now emerging at the intersection of different technologies, whether the physics, chemistry, biology, where they intersect. A lot of new technologies are coming out, and this is what is driving the progress in the world. STEM. It's STEM. It's not buying and selling. It's it's engineering. It's science. It's medicine that is driving the progress forward. So I'm a neuroscientist and a budding entrepreneur. My journey was not linear in some sense. So, but I started with a passion in chemistry, and then I it turned into passion in biochemistry. I love neuroscience, and eventually I just dedicated my entire career to neuroscience. But it just happened so that the life just puts you into this route of serendipitous encounters, and it turned from an academic career into a career of entrepreneur. And I tried it, and I liked it. I think the first person who never had any failures would have to throw a stone at me. One of the examples would be when I was doing my my PhD. It just happened so that my supervisor, he had to leave the university amongst a couple of other people to go to a different place, and then I had to start a new project from scratch. And when I started that new project, again, the same thing happened. It was like the round of redundancies happening at Imperial College London. And that on the one hand really put me down from pursuing a career in academia. It put me down from finishing that PhD. But I ended up persevering. I ended up pursuing this goal, finishing the research. Actually, this is not a linear path. This has taken me on that independence has taken me on a completely different path to where I started, and forming a whole new hypothesis that resulted in a paper in eLife. It took me a lot longer than it would have taken me if it was a linear path, but I got there in the end, and what it has taught me is it has really taught me to just grind your teeth, persevere, and be resilient.
Perfect. Excellent.
So young people should be interested in following a career in STEM, because at the moment I think there are great opportunity coming with all these data that are created in general with science. So we see a huge amount of data created with, for instance, biology that I work with, and we can see that it's going to bring more and more answer on health, disease, and how to understand how human body work and how we can fight disease. And I think there is a great opportunity there to try to find solution. So if students are curious about that, I think it is a great time to come and try to understand what to do with this data to find out solutions. So it was when I was very young. I was inspired by the father of one of my friends who was a scientist himself working in a laboratory, and I remember being fascinated by hearing what he was doing, because I think he was the only scientist I knew, and really feeling inspired to follow this career path. So I think that's really what started the sparkle, I would say, for science, and made me follow this path afterwards, after high school. So what has been my journey? I actually studied in what we call an engineering school in France, so towards biology more than engineering, as we would hear it maybe in the UK. And after that, I came to the UK to do my PhD in what we call metabolomics, so it's looking at the metabolism of a system. So that's where I started to be in contact with big data. And from there, I moved to Twins UK, which is a cohort of twins where we study how genetic and environment can influence health and disease.
Excellent.
Well, I think I wouldn't say there was one failure. I think everyone has many failures, unfortunately, but what I saw is that I always had something next coming up, and that was always interesting, and that always actually made me happy. So there is always this job you want, you don't get it, and you get another one, and at the end of the day it's fine, and you learn something else, and maybe it's not what you expect, but I think if you keep your mind open to learning and discovering something new, whatever comes up is always of value. So yeah, I think to keep that in mind is important.
I mean, young people should be excited in the areas which are most exciting, and that is technology. I mean, technology and science, all of this, it's totally changing the world. It's changing the world more rapidly than it ever has before, and it's changing each of our lives more profoundly than it ever has before. You know, whether it's genetics or it's the internet or it's space travel, I mean, there's nothing to not be excited about when it comes to this. I am a researcher of the internet. I mean, specifically what I really look at is what the internet's doing to all of us, how it's changing society, politics, media, crime, warfare, all of those things. And I guess like many researchers, especially in think tanks, it's a bit of a winding journey really. So I kind of began life as an academic, and then kind of social media happened, you know, and I just thought this was just the most profound research opportunity for a generation. I mean, all these amazing data sets to understand ourselves better, but then also, you know, social media was obviously a huge agent of social change at exactly the same moment. So those two things came together, and I just needed to change what I did in order to try and deal with that. You know, both, you know, profound in the opportunity to study society and to study also the thing that was changing society so much. I mean, diversity is unbelievably important because everything that we know about tech, you know, is that both in who makes it, what is made, and how it's done, all of our different kind of things that make us who we are, our identities, where we grew up, the languages that we speak, who we know, they all come together to inform that massively. I mean, tech is not neutral. Tech is a series of decisions, whether it's an algorithm that shapes what you see online, whether it's the way that a platform is built, or whether it's one platform rather than another. All of these are decisions, and we can't have those decisions just coming from one slice of society, because then it doesn't work for anyone else.
So I started doing computing at the age of 13 in the 1980s. I started off by doing computer science at school. Then I went to do a degree, then a PhD. Worked in industry for a short time, hated it, and then decided to stay in academia. And I've really enjoyed it ever since. My particular area of focus is on small, tiny computers that form a network with each other, and they're called wireless sensor networks. And they can be used to allow us to understand whether a bridge is falling down, the state of a road, water networks about to explode, those kinds of things, and allow us to get an early warning so we can do something about that. I'm also at Imperial College in the Department of Computing. My job there is a professor of computer systems, and I do research on those kinds of systems. But also I have another role, which is the chair of the Equality and Diversity Committee, and that chair is to look after the students and the staff to ensure that we have equality, and to make sure that the staff themselves are diverse in terms of backgrounds, in terms of outlooks, and so on. Young people should be excited about STEM careers and technology because of many reasons. One, the actual topic itself is very far-reaching. The jobs that you can get are jobs that you can control. You're not so much told what to do by a boss. And the salaries are actually amazing quite well as well. And for me, I've been able to travel the world and mix with people who are not necessarily in STEM. So it's a lovely mixture of everything, and so many opportunities. Okay, diversity is very important in the world of STEM because, well, let's look at STEM at the moment, especially in computing, for example. Computer systems are now controlling a lot of what other systems we have out there, the water networks, when a bridge works, robotics and so on and so forth. Now, those systems, if they are just built and trained to be used by one set of people, then those systems are starting to make decisions based on the kinds of ideas and perceptions of that one sort of people. As Karen Spark-Jones says, computing is too important to be left to men. Well, I think it's just too important to be left to one sort of person. So the failures that I've probably had to face were mainly because of my own background, which wasn't exactly affluent. And also I grew up in Northern Ireland during the Troubles and so on. And so a young lady from in the middle of the countryside wasn't expected to go on to university. So overcoming the perceptions that people expected somebody like me maybe not to go into such a career was a start. But there's nothing nicer than proving people wrong. And actually the challenge itself is quite exciting, and to be able to do it and be successful is just a wonderful feeling. Yeah.
I work in health technology, and I run a company called Collider Health, which accelerates innovation in the health space, and I build ecosystems for sustainable change, working with government, corporates, third sector, SMEs. And the reason why I started Collider Science, and it was actually a few years ago, was I have 3 sons, and I could see a growing disconnect between how our kids were being educated and what I could see in the hot end of the world that I was operating in science and technology, with things exploding, developing so quickly, with the pace of change, completely disrupting industries, jobs, and really I could see this ever-increasing need for our young people to see themselves as masters of their own destiny, and the kind of skills that you really need to really cope in this very uncertain, changing world are the ones that you don't necessarily learn in school, and that's about entrepreneurship, creativity, and actually seeing the opportunities of science and technology in a way that perhaps you don't really get in school. So that was the reason why I set up Collider Science, and I just felt science and technology needed to be seen in a different way, and I felt to be a bit more, I guess, inspired, by what we're seeing in the hot end of all the developments that we're seeing today play out in technology industries coming out. Well, so I think the opportunities are significant. We are seeing already there's a growing skills gap in terms of what kids are being taught in schools and actually what employers are actually requiring. So we're seeing, for example, data scientists. Every single company is in desperate need of data scientists. There's a huge shortage of them. There's a huge need for creative thinking and critical problem solving. These are all the skills, especially when you're working in grey areas and when you're actually innovating and actually searching for solutions to new problems. It's about thinking very, very differently. So there's this growing need to, A, develop the hard skills, especially in maths and computer science, but also the soft skills to be able to apply these hard skills in ways that are actually about solving new and emerging problems as we're seeing today. Diversity is important because it's connected with power. At the moment, we see a lot of power in the hands of white men. I think in emerging fields like artificial intelligence, we need more women leaders actually making the decisions of what we're seeing having a tremendous impact in society, and ever more so. We need to deal with things that are becoming more and more important in terms of bias. A lot of algorithms, are being trained on data sets which come from very specific segments of society. So we need to make sure that we are making sure that we're training our algorithms and developing our artificial intelligence using data that is more reflective of the world and that we're solving problems for real people. I think we already see in the tech world there is a huge shortage of women in the tech fields. In health technology, about 9% of women are actually running their own businesses, and that needs to increase. And there's also an issue around the investment community, which is dominated by men. So of course they tend to favor businesses developed by male founders. So I think there's at all levels, and I think even looking at the impact of what everyone is seen as a huge threat in job automation, most of that impact, or the majority of that impact, will be hitting women. So I think we have to see and make sure that we make decisions that are actually going to be fair, equitable, and make sure that we're not creating a society of the haves and have-nots any more than we already do. In fact, technology should be used to reduce that gap, not widen it, which is actually the big fear at the moment, which is why diversity is so important.